Hello, today we're going to put everything we learned about solving quadratic equations into word problems. The first type of word problem we have is when we drop an object. When an object is dropped, its height h in feet above the ground after t seconds can be modeled by the following function. H equals negative 16 t squared plus h sub 0. Any variable with a sub 0 represents the initial, so h sub 0 represents the initial height. The model assumes that the force of air resistance on the object is negligible and works only on the Earth. Okay, so let's just go ahead and get started. This one, if you notice, I put how we're going to solve each of the equations, but we'll talk about other ways as well. So this example, we're going to solve quadratic equations by square rooting both sides, because we're only going to have one variable to solve for, so we're not going to have an x squared and an x term. Okay, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does it take for the container to hit the ground? So we are going to use the h equals negative 16 t squared plus 50. Oh no, plus h sub 0. We'll plug in what we need to plug in. Okay, we want to find the time when it hits the ground. So our ending height is 0 because it hits the ground. There's no height. We are going to solve for t squared, and our initial height is 50 feet because that's where we're standing when we drop the container. Now look, we only have a t squared to solve for. So we're going to go ahead and subtract 50 on both sides. We get negative 50 equals negative 16 t squared. We're going to divide both sides by negative 16. Okay, and what I usually do at this point is I just have 50 over 16 equals t squared, and then I square root it on my calculator. I want you to be careful here. I'm just saving myself a step instead of dividing and then repunching it in and putting the square root on my calculator. So punch in the square root, put parentheses, 50 divided by 16, and close the parenthesis. That's very important so that both the 50 and the 16 are underneath the square root sign. When you do that, make sure you try this. You get 1.8 seconds. Just round to the nearest tenth. Okay, so we are I'm going to have you use the same equation, look what I plugged in, and go ahead and try the U-try on your own. Okay, welcome back. Now we're going to talk about objects that are launched. So now we have a different equation. We have negative 16 t squared plus v sub 0 t plus h sub 0. So 8 is our height, t is our time, v sub 0 is our initial velocity, t again is time, and h sub 0 is our initial height. So we're going to refer to this equation as we go ahead and start the first problem. Okay, the height, h in feet of a baseball t seconds after it is hit is given by the following function. Find the maximum height. So you're given everything you need in this situation. We don't need to plug anything in, but we do need to solve for maximum height. So maximum height, we're not finding time. Maximum height is the vertex, because remember we have a parabola. We want to find how high can this go. So a couple ways you can do this. You can go ahead and do your negative b over 2a and find your vertex, or because we recently learned completing the square, we can complete the square to put this in vertex form. So either way will work. Okay, if you want to do this, this is choice 1. Make sure you solve for whatever you get here for the x of the vertex, and then you plug it in to get our y of the vertex. But I'm going to show you completing the square because that's what we recently practiced. So we're going to go ahead and set this up. We're going to have h plus blank equals factor negative 16 out, t squared minus 6t plus blank plus 3. So go ahead and find what that blank is. So take negative 6 divided by 2, square that, so we get 9. Now be careful. Remember, we're adding 9 to the right, but we're not adding 9 to the left. We have to do negative 16 times 9, which is negative 144. So we're adding negative 144. So when we do this, we're going to go ahead and factor our perfect square trinomial, leave our negative 16 alone. We get t minus 3 squared plus 3. Now we just have to add 144 to both sides. And when we do that, we get h equals negative 16 t minus 3 squared plus 147. Now this, we can just see the vertex. Our vertex is 3, 147. So what's the maximum height? 147 feet. So either way, it's about the same amount of algebra. If you want to do this because you have to plug it back in, but either way you should get 147. Okay, so go ahead, pause the video, try the U-try on your own. We're going to glance at it before I go on to the next page. You're going to do the same thing. It's okay that there's a decimal here. Just deal with the decimal, use your calculator, it's okay. You can complete the square, or you can do negative b over 2a. I want everyone to make sure they come in with an answer tomorrow, but you are finding maximum height, so we're doing vertex. Okay, the last type of example is where we're actually solving for time. So we need to use our quadratic formula or factor. We're actually solving for t on these problems. Same equation as the one above. So it says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3. How long is the ball in the air? First thing I'm going to do is write down the equation we saw on the other page, and then plug in what I know from the word problem. Okay, so we know that the ending height is going to be a back of 3 feet. We don't know t, that's what we're solving for. We know the initial velocity is 40 feet per second, and the initial height is 4 feet above the ground. So this problem, we want to get it equal to 0. So we have 0 equals negative 16 t squared plus 40 t plus 1. And this problem, I don't know if it's going to be simple to factor. We can't, no, actually we're not going to be able to factor it, so we have to use the quadratic formula. So this is A, this is B, and this is C. We're going to go ahead and plug all our information in. We get negative 40 plus or minus 40 squared, which is 1600, minus 4 times negative 16 times 1, all over 2 times negative 16. So when I simplify this, I get the square root of 1664. Now on my calculator I would get both answers because you want to know which one is a positive and negative. So if I do negative 40 plus square root of 164 divided by negative 32, I believe I get, that's plus, I believe I get negative 0.025. Then I'm going to do negative 40 minus the square root of 1664 equals divided by negative 32, and I get 2.5. You can't have a negative time, doesn't make sense, so our answer is 2.5 seconds. Now again, I want you to try exactly what I did in this problem, and I want you to try the U-try. Now one thing I want you to notice in the U-try is I ask you 2 questions. I say, how long is the volleyball in the air until it hits the ground? That is solving for t. That's what I did above. What's the initial velocity? The initial vertical velocity of the volleyball, we don't need to do any solving for. That's our v sub 0. So I'm asking for a v sub 0, which your answer is 48 feet per second. Okay, you should know these 2 formulas and understand what they mean. So make sure you know the first equation I gave you and the second equation I gave you, and like I said, what these things mean, because you are going to need to plug in your initial height. Sometimes you're going to be asked what the initial velocity is. You might need to plug in the initial velocity. You need to know, are we finding a maximum height? Do I need a vertex? Or do I need to solve for t? Am I doing the quadratic formula? So you need to understand the difference between those. Any questions, comments, or concerns? Go ahead, write it on the bottom of the paper, and I'll see you tomorrow in class.